Okay, so in this video I have a quick demonstration for you. So here, I always try to keep my demonstration simple, and so here I have two rubber bands, and I'll be using a scale, small piece of scale. So you can try this at home, and I actually strongly suggest that you try this at your home because this will actually help you understand the whole concept very easily. So this is a very simple concept, okay? So here I have two rubber bands. The first rubber band here is actually a very stretchy one, okay? So it is very easy to stretch. So I can apply. So it does not take much force to apply this to stretch the whole rubber band. And the second rubber band is a very tight one, so I have to apply a lot of force to actually stretch this one. That's the only difference between the two rubber bands. And the third thing is the scale. Now before we actually start the whole demonstration, I'd like to tell you a few things. So first of all, I hope you know what energy means. Okay, so I also hope that you know what potential energy means. So I have a rubber band, and if I stretch the rubber band, it gains some potential energy. So potential energy simply means the ability to do work. So if I stretch this, and now it has the ability to do work, it has some potential energy stored in it. Okay, it has some stored energy, and if I leave it, ouch. So that energy gets converted into the sound energy. Okay, and also it hits me. So that is potential energy. Now if I don't do any work on it, okay, so what is work? I have to apply some force on it and make it move some distance. So that is what work is, right? So if I don't apply any force and leave it as it is, I don't do any work, it won't gain any potential energy. So I have to do some work on it for it to actually gain some potential energy. So okay, and just by using our simple idea of conservation of energy, we know that okay, so work is also energy. So the amount of work that I do on it, so this is the amount of work that I've done. Let's say 5 joules of work has been done by me on the rubber band. So the rubber band actually gains a potential energy of 5 joules exactly. Okay, and then if I leave this, it gains some kinetic energy, and then it dissipates some sound energy and other energies. So all those energies, if I add them up, they'll also sum up to 5 joules. So the work done is equal to the potential energy gained, and then the work that the rubber band does is also 5 joules. That is simple conservation of energy, because you cannot destroy energy, so it has to still 5 joules everywhere. Okay, so now let's get back to the demonstration. So in this demonstration, we'll try to analyze work and the factors that affect work. Okay, so the first factor, okay, so actually I believe there are two factors. So the first factor is the force you apply. So obviously for some work to be done on this, you have to apply some force. Without applying any force, I can't pull it. Okay, I can't do anything with this, so I have to apply some force. So there I apply some force, and then okay, so that is one thing. And the second thing is the displacement. So I have to pull this and displace the rubber band, this edge of it, pull it, so as to for it to gain some potential energy. And it is very clear, if I stretch it this much, it okay, so if I stretch it for example this much, it does not do much work. But if I stretch it this much, so if I have a higher displacement, it will actually do a lot of work. Okay, so it travels a longer distance, so it does much more work. Okay, so that is clear. The more that I displace the rubber band, the more that it gains the potential energy. So that is one thing, and the more that I do, the more is the work done by me on the rubber band. So now let us analyze the second factor in a bit more detail. Okay, so yeah, let us just do it. Okay, so here I have the scale and the two rubber bands, and so now first let us use the looser rubber band. Okay, the which is the stretchy rubber band. So I'll just keep the first rubber band there, and now okay, so here as you can see, the original length of the rubber band without stretching is around 7 centimeters. So if you can see, this comes out to be 7 centimeters here. Okay, now if I stretch the rubber band 5 centimeters more, okay, so I increase its length by 5 centimeters, so I go to 12 centimeters. Okay, so now I have I've given it a displacement of 5 centimeters by applying some force. Obviously the force that I apply in this case is not very much, because this is a very stretchy rubber band, so I don't have to apply much force. And now I have applied some force and done some work on it, and have given it a displacement of 5 centimeters, and I'll just launch it towards that side. Okay, so it goes there. Okay, now I'll take the second rubber band now, and if you see, the length of this is actually 5 centimeters without elongation, without stretching. Okay, it's 5 centimeters. Now I'll stretch it by 5 centimeters and reach a displacement, okay, a final length of 10 centimeters. So I have displaced it 5 centimeters, which means I have given it an equal amount of displacement in this case also. So both the rubber bands have been stretched an equal length, okay. But in this case I have to apply a larger force because this is a much tighter rubber band, so I have to apply a larger force in order to give it the same amount of displacement. Okay, so let us just see how far this one travels. So I have launched it in that direction, and now what we can see is that the rubber band which has gained more potential energy, or the rubber band which has more on which I had done more work, will actually travel further. So let us see which one has traveled further, and the one that has traveled further will have would have gained more potential energy, and I would have done more work on that. So let's go there. Okay, so this is the place where my first rubber band landed. So this was a loose rubber band on which I had applied less force. And if I travel further ahead, this is the second rubber band. This is the place where the second rubber band has landed. So this rubber band here, which was the tighter rubber band, has traveled a larger distance. And I had applied more force on this one, okay. Although both the rubber bands had equal displacement, this one had I had applied a larger amount of force on this rubber band, and this one traveled a larger distance. Okay, so let us continue the same thing on the board now. Okay, so now we can look at the same demonstration, okay, on the board also. So let us look at the work that I've done on the rubber bands, okay. So work done is proportional to, so first of all it is proportional to the displacement, okay, displacement of the rubber band. So the one that had, so it is very clear, the more I stretch, or the more I displace the rubber band, the more will the more will be the work done on the rubber band. So if I stretch it this much and then I stretch it this much, so in the second case I have done more work on the rubber band, okay. So it is clearly proportional to the displacement, okay, done. And also work done is proportional to the, so let us look at the second thing also. So in the case of the two rubber bands here, I had applied a higher force on this one, okay. Although I had displaced both of them equally, I had applied more force on the green one, and the green one had traveled a larger distance, which means this one has had more energy, more potential energy, which means this I had done more work on this. So I had done more work on this, and I had also applied more force on this. So which means force is clearly directly proportional to, work is directly proportional to force. So I had applied a higher force on the green one, so I had done more work on the green rubber band also, okay. So it is proportional, and I can combine both of them to get work done equals force times displacement, okay. And I don't have any proportionality constant here also, because the proportionality constant is simply equal to 1. Okay, so that is how we look at the work done. So yeah, that is the end of the video, and let's continue in the next video.